Hey guys, a warm welcome from your BCM guru from Let's Make BCM Easy for Architecture students. So today I'll be taking the second semester module 4 according to the 2015 syllabus, the types of stairs. But in this video I'll be focusing on the spiral stairs as many students are asking me to take this topic as it's very difficult for drafting. Yes, it is, but I'll make it easy for you guys. And plus, my juniors have the submission tomorrow. So let's start with the spiral stairs. A spiral stairs is a type of continuous stairs. And what is a continuous stair? The stairs which do not have any breakage in the flight between the two landings. That is, in other type of stairs, you climb up, there's a mid landing and there's a final landing that is on the top. So, but in this case, when you climb up, there's no mid landing. You directly land on the next floor. So, in this, the types are the circular stairs, the spiral stairs, and the helical stairs. The circular stairs and the spiral and the helical stairs I'll be covering in my in the next video. The brief introduction about the spiral stairs. They're usually made of RCC or metal, and it is employed at location where there are space limitations. Yes, and also used as emergency stairs and are provided at the backside of the building. Also, all the steps are winders. Okay, what is a winder? The You have seen the rectangular steps which have equal width on all the sides. So this part, the winders means it the step is narrower at one end and it is wider at the other end. The width varies. So and this is used in the change of direction while ascending a step or descending. So and when you are drafting a staircase in the architecture plan or when you are making a staircase, so avoid winders as it is not comfortable for using. So in spiral staircase, everything is a winder. So for change in direction, you use a winders. So a series of winders makes a spiral stairs. That's why it's easy for, as I said, it's for changing the direction. So it's not comfortable for using it. So avoid winders in your other type of steps. So, and guidance for the drafting. Like, in this one, I'll be sharing you the measurements, how to do it. So, first is the staircase radius. What is the staircase radius is from the center of the central pole to the outer edge of the handrail is the total radius of a spiral staircase, and the radius varies from 600 to 1500 mm. You can choose this according to the space available for you. And the rise, yeah, just remember in this the rise is not same as what you use for the normal stairs, that is the 300 mm thread and 150 mm rise. So here the riser varies from 160 to 220 mm. So what is the rise is the vertical distance between the two successive tread faces. So the nominal size is about 170 to 180 mm. You can take anything between 160 to 220 mm. This depends upon according to the height which you are drafting, like according to the floor to floor height. And this is now like at what height should be the railing. The railing should be at a height of 1100 mm, that is 1.1 meters. And sometimes two railings are provided, like at 900 mm and plus 1100. That this one is optional, it depends upon your design. And now comes the handrail dimension. So the handrail which you use for the climbing the staircase is a steel tube that is 42 mm diameter. You can have it in 50, 60 mm. So this PDF I got from a company website. So there they use it as 42 mm. So it depends upon you. And yeah, in drafting you can't show 42 mm, just show it as 50 mm. And for the child safety, the railings which are there in the balusters or the railings, the distance between the two shouldn't be like more than 100 mm, otherwise a child can fall. And yes, the clearance to the wall. So this is the spiral staircase and this is the wall. This is basically in a case, spiral staircase. So this one you leave a gap of 50 mm on all the sides of the stair. And now how to fix the spiral stairs. So sometimes like you use stays to fix it to the wall, and sometimes it will be in the middle of the, like sometimes in the middle of some space. So directly you can fix the central pole to the base below. I'll be showing you in the next slide. And yeah, how to fix the landing. As I said, there is only one landing. There's no mid landing. From the ground floor, when you climb, just imagine from the ground floor you're climbing and you reach the first floor. There's only one landing and there's no mid landing, as it's a continuous stairs without any break. So use suitable type of bolt. Yeah. So there will be a plate, and this is the landing where you keep the foot, and this is the slab on which the plate is fixed with the bolt passing through it, the plate and the bolt. And this is the base plate fixing, that is the central pole on which the spiral stair on which the steps will be fixed. So this is the 150 dia base plate which will be fixed to the base, that is the floor, with the bolt and another similar as this. And this is the central pole, this part. So the central pole will be welded to the base plate, and this one will be fixed to the floor. And the headroom, as you know, so the minimum headroom dimension, that is from the tread to the above surface, that is the ceiling or the soffit of the staircase, that is, so that your head shouldn't hit that thing. So it's basically 2.1 meters, or in this case minimum is 2000 mm, that is 2 meters. So you shouldn't give less than that, otherwise your head will hit the surface. And yes, this part is number of steps per revolution. You will be thinking how many steps to give in one spiral, in one round. That is when you climb from one, you go from one floor to another floor. Like how many steps to give. So basically you can follow this. So here they have just mentioned the staircase radius as 600 mm, 700, 800, 900, 1000, 1.1, 1.2, yeah, till, as I said, the radius goes from 600 mm to 1500 mm. So these are the staircase dimensions that should be aimed for, and these green lines are the normal staircase, number of steps in a staircase. So yeah. Now here comes the fun part, that is the drafting part. I know you guys love drafting. So now I'll show you my sheet picture, like how to draft one A1 sheet with composition. So this is my sheet picture. In this I have a plan, one elevation, and this is the key plan. Yes, in a BC sheet never forget to make a key plan. So this is the building and my spiral stairs existed here. So and these are the tread, riser, elevations and detailing, and this part is how the spiral staircase is. This is the fixing part. So now I'll explain you how to draw the plan of a spiral stairs. So first you need to choose, according to the space dimensions, what is the feasible radius. As I said in my previous slides, the radius goes from 600 to 1500 mm, and it's taken from the central part of the central pole to the external radius. So from the central part of the central pole to the external edge of the handrail. Yes, now I got it. Yeah. So in this case, I have taken 1500 mm as my radius. So total you can see 3000 mm. So first draw a circle of your defined radius, then draw a straight line. Then this is 1500 mm. I have taken it 750 in the middle. Draw a guide circle. So if you have taken 600 mm as the radius, so you will draw it as 300 mm. I have taken 1500, so I have drawn a circle at 750 mm. And now, how to take the dimensions? So in the other types of stairs, you would have seen the you take the entire width as 300 mm and the riser is 150 mm, and this is a winder. It is narrower at one end and wider at the other end. So in this part, when you draw a central circle, the central part should be 300 mm where you keep the foot. It shouldn't be either here or maximum. This is the maximum part, but this part you need the 300 mm. So what you do is you draw a circle, then a straight line, and then you draw a central, take half of it and you draw a central circle. From here, this part, you take 30 centimeter, that's 300 ka arcs. Then from the central pole, you just draw the lines. You will get the number of steps in a revolution. So in this case, I got 15 steps as my height was somewhere around 3.4 or yeah, 3.4 or something. So this one I have taken as 220 as the riser. In this I got 15 steps. So after drawing the plan, you take these lines and just pull on top and then make horizontal lines, then darken it. You yeah yeah, you'll understand it better. So a central pole, ground line, this one, that's the finished floor level, then these lines, and yeah, it should be fixed to the central pole. As you see, this one is the central pole and this is the tread. Okay, now I'll come to the detailing part. I hope you can get this. If you have, if you're having any doubt, you can email me or just yeah, or just I'll share my number so in the description below. So now we'll come to the detailing part. This is the tread, riser, and this is the detailing. So this is the tread of 1.37 and I have taken the width as 0.58 meters, and this is the riser. So how it works is, this is the hole for the central pole to be inserted. So this is the tread, riser will be welded here, and the pole ka space. So the pole will be, so this will be inserted from top in the pole, and this part will be welded to the consecutive tread. So this riser will be, the tread will be welded to the consecutive riser on top. And this is the hole for the central pole, as I said. Now how to fix the central pole to the base. So this central pole will be welded to a base plate and the base plate is bolted down to the floor below. See this, the metal plate is fixed to the floor with screws. The central pole is welded to the main plate. So I think, yeah, and this one, landing details. Sometimes you get like the stairs ends at the proper floor level, but when there is a gap between the stairs, spiral stairs and the consecutive floor, you make a landing plate. You go on top. So as I have you as have I shown you this? Yeah. So this is how the landing plate is fixed. So this is the landing plate and this is fixed with the bolt. So these details, so these are the details you can draw to fill up your sheet. So yeah, one more important thing about BCM is, so plan elevation is necessary, but to make your sheet look more nice or more aesthetics, you draw these kind of detailing. In this case, I have taken metal staircase, metal spiral staircase. So these are the welding, and like you can do better now. This was nice, I can say. So nowadays you can either do a composite stair, that is a mix of metal and glass, and as I said, it's made of RCC and steel. So you can do this. So these are the zoomed images. You can do a plan, then elevation, and yes, guys. So I'll take a video about the components of stairs, but this was urgent, so I took this. So this one, just label your sheet as tread, riser, central pole, handrail, base plate. Draw these detail as fixing it. Then how these part are fixed to the central pole. Draw the handrail detail, and this one is the landing details. Then these things you can just do to fill up your sheet and make it look good. And thank you for watching the video. If you find the video helpful, please like, comment and share, and please comment in the description below. Thank you guys.